Hello. In this video, we're going to look at some operations with rational expressions. Starting with multiplication and division, which are the simpler of the two operations. Recall that with numbers, we can just multiply across the numerators and multiply across the denominators and then simplify. But simplifying involves factoring, which is the exact opposite of multiplying. So in fact, our lives are easier if we factor first. So if I think of this as being 15, for example, is 5 times 3, and 25 is 5 times 5. 16 I can express as 8 times 2. So then before I even bother multiplying out, I can cancel or divide out the common factors. And that makes my multiplication step and my simplification step easier. Now with numbers, you can usually get away with not bothering to do this. But with polynomials, we definitely want to factor and cancel common factors before we multiply, or otherwise we make the simplification step way harder than it needs to be. Plus, we introduce the potential of errors when we're doing distribution that we didn't have to do in the first place. So if I look at these two examples here with these rational expressions, my first step, therefore, is going to be to factor. So 2x plus 8 is 2 times x plus 4. And that first denominator factors to x minus 5 times x plus 2. In the second fraction, the numerator becomes x plus 2, x plus 1, and the denominator is 2 times x squared minus 16, but x squared minus 16 factors one further step to x plus 4 times x minus 4. At this stage, I can see that there are factors that will cancel out, the x plus 4 and the x plus 2, as well as the 2, which means that now my final fraction is going to have a numerator of x plus 1. I like to keep it in brackets just to remind myself that that is a single factor that can't be broken up, although you don't technically need the brackets in the numerator here. And then x minus 5 times x minus 4. So this is the simplified fraction for that multiplication. You don't have to bother redistributing everything out, but we do have to consider the non-permissible values, the restrictions on x. The obvious ones are that x can't equal 5 and x can't equal 4, because those are the factors that I can see in the denominator of my final simplified fraction. But I also do have to take note that the factors I canceled out, again, remembering that canceling is really just dividing. So I couldn't have divided out those factors if they were 0. So that means that the restriction is still that x can't equal -2 or -4, in addition to the 2 that I noted above. So just because a factor canceled doesn't mean that that restriction or that non-permissible value goes away. We have to consider anything that was in a denominator at any point. If I look at the next example, which is a division of fractions is pretty much exactly like multiplication of fractions, except we have an initial first step of inverting the second fraction, inverting the divisor so that we can turn it into a multiplication. So I'm going to combine my factoring and flipping steps here. So the first fraction doesn't change. I'm just going to factor it as is. So I get 2x minus 1 times x minus 6. And the denominator, x plus 7 times x minus 7. But in order to turn this into a multiplication, the denominator of my original problem becomes the numerator here. So this becomes 3x minus 21, which I'm going to factor to 3 times x minus 7. And 4x squared minus 4x plus 1 becomes the new denominator, and that is 2x minus 1 times 2x minus 1. Now that it's a multiplication, I can do exactly what I did above. I can cancel out or divide out the common factors. And what I'm left with as a final simplified fraction, in the numerator I have 3 times x minus 6, and in the denominator, x plus 7 times 2x minus 1. So that is the simplified quotient for these two polynomial or rational expressions. My non-permissible values, all right, so I have the x cannot equal -7, x cannot equal 1/2. Those come from the two factors that I can see in my simplified fraction. X also can't equal +7 because I had a factor that canceled out right here. The other one that canceled was 2x minus 1, which is still reflected. So I already have the x can't equal 1/2, but now I have to include x can't equal 7, +7. But this is a division, so I actually have an additional place to look for non-permissible values, and that is the numerator of my second fraction. The reason is that used to be in a denominator. So basically, everything that I've now highlighted in yellow has to be considered for non-permissible values. Anything that was ever in a denominator at any point. In this case, that doesn't introduce any new non-permissible values because I already considered x can't equal 7, but I do have to look there because in some cases it will introduce new non-permissible values. The more complicated operation for fractions, the more complicated operations are addition and subtraction, and that's because we need a common denominator. So to recall from numbers, I can find a common denominator just by multiplying the two denominators together, 4 and 6. We don't want to do that with polynomials because it makes for a higher degree than we need and makes simplifying harder. So what we actually want to look for always is the lowest common denominator, and for that we look to the factors. So in this example given, 4 is 2 times 2, and 6 is 2 times 3. They already share a common factor of 2. So that part of the denominator is always already the same. I only have to multiply to get the factor that's missing. So in the case of the first fraction, I'm missing a factor of 3, so I'm going to multiply that fraction times 3 over 3. And in the second fraction, I'm missing a second 2, so I'm going to multiply that fraction by 2 over 2. So my lowest common denominator is actually 12, which gives me the fractions 9 twelfths plus 10 twelfths, or as a final answer, 19 twelfths. And then I double check that I can't simplify that fraction. 19 is prime and shares absolutely no factors with 12, so that is already simplified. So now if I look at these two rational expressions, looking at the first one, 5 and x are the two factors that I have in the first fraction. 5 is already a factor then of 10, and x is already here. So this is 2 times 5 times x. So all I really need to do is multiply that first fraction by 2 over 2 to get a common factor of 10x, common denominator of 10x. So this is 6 over 10x minus 3 over 10x, which ends up being, as a final answer, 3 over 10x. Because I do have a variable denominator, I have to consider non-permissible values, and in this case, x cannot equal 0. For the second example, I have a situation where I don't have just multiplication in the denominator. I have x squared, which is x times x, that is just multiplication. But then x squared plus 2x, so I need to express that as factors. So in other words, x times x plus 2. Now I can see that while there is a common factor of x, each fraction is missing something from the other. So in the first case, that's the factor of x plus 2, which is missing. So I multiply the numerator and the denominator both by x plus 2. And in the second fraction, it's a second x. So I'm going to multiply both the numerator and the denominator by x. So what this gives me in the first fraction is 1 times x plus 2, which is just x plus 2, over my new common denominator, which is x squared times x plus 2, and then plus 1 times x, which is just x, over that same denominator, x squared times x plus 2. Now that they have the same denominator, I can add together the numerators. So x plus x is 2x plus 2 over x squared times x plus 2. And then I factor my numerator just to make sure that everything is as simplified as it can be. So I have 2 times x plus 1 over x squared times x plus 2. There are no common factors, so this is the simplified sum. My non-permissible values, anything that was in a denominator at any point. So x cannot equal 0 because x squared can't be 0, and x can't be negative 2. Those are my non-permissible values.